Alright, and here we are at the bottom of page 1 for 3.3. And let's do a couple examples. And the instructions are actually back up at the top of the page, but it says to find the perimeter and or the area of each problem, or of each figure. Okay, so we'll actually do the perimeter of both of these ones to watch. I won't have you do the perimeter of the try problem because they don't give you all the information to be able to do the perimeter. Perimeter, again, is just adding up all the sides. So the try problem will just be the area of that figure. Okay, so let's work through this here. Perimeter is adding up all the sides. So for number 2 here, again, it may help you to redraw the picture for yourself so you can really understand. And the little squares here tell you that it's a rectangle. And you've got 4 feet on each of the lengths and 3 feet on each of the widths. And I go ahead and write in any numbers that they don't, so that I don't miss anything. Okay, and then I remind myself that perimeter is adding up all the sides, so then I do that. I do 4 plus 3 plus 4 plus 3, or if you want to think of that as 2 of the 4s plus 2 of the 3s, if you want to use the book formula that's up at the top of the page. Either way, you should get 8 plus 6 or 14. And because perimeter measures a length, a distance around, it's just going to be in regular feet. Okay, you always want to add the label to finish the story. And hopefully you got good practice with that as you were doing your other word problems leading up to this section. Let's do the area now. For the area, it's going to be length times width. You got to recognize what figure it is. It is a rectangle, so that means area is going to be length times width. We're going to write and say our formula every time we use it so that we get it memorized, because our eyes are seeing it, our ears are hearing it, we're having it. We're going to put that into our brain 4 times every time we use it, and that repetition will cause us to have it memorized. Okay, so the rectangle here, I've got 3 feet as my width, 4 feet as my length, so the area is going to be 4 times 3, or 12, and the way we label that is feet squared, or you can write that as 12 square feet. Now why is that? Because what area is, it's saying how many 1-foot blocks will fit in this. So what they're saying is that this, if this is 4 feet, that here each one of these blocks that I could fit inside of it would be 1 foot by 1 foot. This is 1 square foot. 12 of these can fit inside this rectangle. That's what an area is. Okay, so 12 square feet is the area. So area is 12 square feet, perimeter is 14 feet. So very important on those labels. Start getting some good practice with that. Okay, let's do number 6. Again, perimeter on this one, we're going to add up all the sides. And I'm just going to redraw it to help myself here. And with perimeter, I don't need this inside height. I just physically need what would, with the lengths to create a fence around the outside. So 21.1 meters, 26 meters, 18 meters, and 37 meters along this side all the way to the ends. Let those arrows tell you what that number represents. You don't want to get caught using just a partial number. You want to make sure it represents that whole side. So my perimeter here is going to be, we'll do the 21.1 plus the 26 plus the 18 plus the 37. Sorry, my 18 got a little squished there. And again, you are free to use calculators here, and in doing that you should come up with 102.1. Whoops, 102.1 meters. And again, it's a distance around for perimeter, so it's just plain old meters. You're just looking for how many little meters would it take to go around this. Okay. And then on the area, it's a trapezoid. So, and how do I know it's a trapezoid? Well, a rectangle has all right angles. A trapezoid is 4 sides where one or more of the widths, the sides here, are slanted. We've got top and bottom are parallel, but you've got slants on the other one. So a rectangle is also a type of trapezoid, but if you were to average the 2 lengths, that half A plus B, you would just get the plain old original length, because you'd have two of them, then to cut that in half you'd have one of them, then you times the width. So the trapezoid is just another version of the rectangle area. And again, those are at the top of the page. So I've got a trapezoid, and that is going to be half, it's length times width, where the length needs to be the average of these two lengths, and they give me 26 and 37, and then it's going to be the height, and the height is the straight up and down right angled measurement, so 18 meters there. So area of a trapezoid is going to be 1/2 times the height times the two bases added together, what would have been the lengths if this would have been a regular rectangle, would have been the length. So it's half the lengths added together times the height. If it helps you, you can rewrite that. If you want to think, hey, it's the average of these two lengths times the height, you could think of it as area is equal to half, or the average of the lengths times the height. So this would be the average of the lengths times the width, and the width in this case is going to be represented as a height because it's not one of the side lengths, it's a straight up and down measurement between the two parallel tops and bottoms. Okay, so in this case, however you want to think about it, you can just straight memorize it 1/2 h times a plus b, or if you want to try to connect it to what you already know about rectangles, it is length times width. It's just that you have to have the average of the two lengths times the straight up and down height has to represent your width in case both of these are slanted. Okay, so what do they give us here? This time it's going to be 1/2 26 plus 37 times our height, which is going to be the 18. And then order of operations, let's do what's inside the parentheses first. 26 plus 37 is going to be 63. And I can find half of that 63 if I want to right now. It will become a decimal, and then I'll multiply by 18. I can just go straight across there with a calculator. I can also use associative properties and commutative and rearrange these and regroup these and take half times 18 first, get 9 times 63, and then when I multiply 9 times 63, I'm going to get 567 meters squared. Sorry, I started to run into the try problem here. We'll go ahead and kind of cut that off. Okay. Okay, so now it is your turn to try. You want to recognize what figure you're doing, and again, just the area. Just try finding area of this figure. Hit the pause button, come back when you're ready to check your answer. Okay, this is a triangle, so you apply 1/2 times base times height to get the area, and you should end up at 495 meters squared. So that's how many square meters would fit inside of that. Okay. All right, we'll see you on page 2.